Notice, talk to after that. So it is the most animated we've been all semester. I almost feel embarrassed to interrupt. So we should talk about a few things. Context. What's the context?
In the state and strategy pattern, that's one of the big players.
And what is the context in that pattern?
Variable name and its value.
What's that?
Variable name and its value stored in the context. Variable name and its value stored in the context.
Well, the spreadsheet is a context, right? So in the pattern, right? In the pattern, there's no context of the pattern, right? It's not, here's the problem we're solving, but here's, I'm describing the pattern in general, right? And so the context is where the state lives, right? Is that it? Did I get it right?
So you're saying there's not necessarily supposed to be a context object?
Correct.
Okay, because the way I read those patterns was you're supposed to have a context object that kind of wraps the state or that wraps the strategy, but then that context object doesn't do a whole lot.
Yeah, it just becomes another wrapper for another thing, right?
Yeah.
And it's like, what's the point?
Okay.
Now with that, it's like, you come across a class called context, I'm going, context for what? Don't know, right? So in some of these patterns, right, there are roles that classes play. And the context is what? A clearer one to talk about is right. What's the originator? So then, mental pattern, right? We have a object you want to save the state of, right, for later use. And what do they call that object in mental pattern? Originator, right? Meaning that is the class we want to save the state of. Because they don't, since they weren't applying a particular problem, they couldn't say, oh, we're going to use the mental pattern to save the state of a spreadsheet cell or a spreadsheet. They didn't have anything, right? And so when you come across a class called originator, it's like, what does it originate? That's not clear, right? And what people did then is they took data out of the cell and put it into an originator class, right? And then so they could take it out of there and put it in a Memento. It's like, No, don't do that, right? So these are, in some of the patterns, some of the participants are labeled by the roles that another class plays, right? Client. Well, what's a client? A client is someone who asks questions of a server, right? So almost all your objects are clients at some point, and a lot of them are servers at some point. Anytime one object calls a method on another object, the first object is a client, and the second object is a server. And so calling a class a client, the only time that really makes sense is when you're doing sort of network programming and it's going to talk to a physical server someplace. Or having a field called client is like, it doesn't tell me what it does, right? So again, it's a role. So these patterns, you have to just have one error, the names involved, just placeholders for things that can play in that role, right? So when we have a memento, the originator is whatever we're trying to create the memento for. And the state pattern here is just it's what the state needs, right, to operate. You want to call it context, at least give it more part of the name so I know what's the context of, right? A slightly different issue. So you've all probably heard of the MVC, right? The model view controller. And right, the issue is when you have a program that has a GUI or some sort of interface, you want the interface part to be separate from the model part, right? In part because the view part has to deal with buttons and dials and text fields and where you put things and all that, labels and all that sort of stuff. And then there's events that happen, and the model deals with the logic of the situation. And right, the goal is to keep those two things separate, right? So ideally, we can write a fully functional model and run it and test it, and then connect it up to the view, right? Or connect the view up to the model to make the whole thing work. Of course, it becomes slightly more complicated than that because the type of view you have, right, may affect how you write the model. For example, in Java, people use the JTable for the view, right, so you can see the cells and text, and that says, oh, what you want is you want a JTable model, right? And the model then says, give me, you told me you've got 4 rows and 5 columns, give me the value for the 3rd row, 2nd column, right? So your model has to then say, okay, here is that particular value. Now the people who did Python, some of them wired up in such a way that, oh, what you did is each individual cell was wired up to a particular cell, and the interface talks directly to a cell over here, right? And so that then drives the architecture a little differently because you're not having to say, I don't have a middleman saying, oh, you want row 3, column 4, give me that value, right? And that changes things. But still the goal is to try and take as much functionality out of the view as possible. Right? So one example is undo, right? So over here, I have a button that says undo, right? And so in Java, in the Java world, what you had is you had a callback function, right? That for the undo, and then some people in that function, they did all the work, right? To do undo. Now, here's your spreadsheet and all the stuff, but you cannot test undo. Why? Well, because it's all triggered. All the logic for undo is stored over here in the view, and so the only way to test undo is to somehow press that button, right? And so you really want to be able to, you want the undo callback method here to call a undo method in your model. Right now, I can make sure that that works, right? Without having to physically run it and press that button. So you want to keep these things as separate as possible. So in a lot of C-like languages, we can have static fields and static methods, right? And that gives you, like a singleton, it gives you a single point of access for a particular function or piece of data, right? And as we talked about in a singleton, right, using static is less flexible than having regular objects and regular methods and then having a singleton version of it. For various reasons. One is we can't pass around static things, right? We always have to do foo.this, right? As opposed to instantiate foo or get the singleton foo and I can pass the foo object around. Now, a lot of people use the static things for two separate reasons. One reason is I call the parser, well, I say, well, there's no state, so I pass in a string, I use this, and I break into 3 functions, 5 functions, and so why not just make them all static? And I'm going, well, maybe why not just make them all regular methods and then instantiate the object and right? And you might find a reason for having state. But the other reason was like, well, you know, there's some stuff over here that I need access to from over here. But I can't get it from over here. It's like over there. So how do I do that? Oh, I know. I'll make this static. And now I can get it over here. And that type of usage often is just you're covering up a bad architecture, right? It's like, well, if I need it over here, why can't I get it over here? Right? So what's the problem? And so they're, I'll just make it static. Like, well, A, why do you need it over here, and why can't you get to that over here, right? Now, of course, there are times when that happens, right? So, for example, in Java, there's a security manager, and you can't pass security manager around to every place in the library that needs it. So, we have a single place to say, give me the security manager, right? But those types of situations are more likely to occur when you're building a library because you can't control who calls what. And this should happen a lot less in a program that you have control over. Um,
Professor, can you please repeat about static? Like in application, if you have a one application util class which have all the static methods, like multiplying two numbers or something very simple mathematics thing for parsing a string. If we have it in a single place in an application, only one file, I'm still not getting. It's wrong, but how?
so, okay, like I said, there's sort of two common places where students use the static here, right? One is, well, I'm in the cell and I need a value from the spreadsheet. How do I get it? Well, I go to the spreadsheet and then I make that field or property static, and now I can get it from the cell.
This is one perspective. Let's
Right.
say I have a perspective, the same thing. I need to have a one place where my whole application can go and see a common functionality. So it's just a two different perspectives.
Right. So your perspective is not this one, right? Where
Yeah.
you're saying, okay, I just need some function. You know, the classic example in Java is math functions, right? How do you access math functions? Well, they're all static. You go math dot sine, math dot cosine, right?
So if this is a perspective, we are fine. We can use one.
Well, again, see, my goal, I suppose, as a teacher, as an educator, is to get you to think about objects, right? And every time there's an escape valve, right, people then start using an escape valve to not do it. And so I want to shut down as many escape valves as possible to get you to do the main idea. Otherwise, you're like, well, there's an escape valve here. I can cheat here, I can cheat here. And in Java, I can't do it this way, I can't do it this way. And so it becomes a lot of places where you can't do it. And if that's always your practice, then we don't get enough practice of doing it the other way. All right. Now, the big place this came up was I need to parse, right? So I have an expression, I have this equation, I need to parse it and return the abstract syntax tree, right? So yes, we could make all of them static and it works. But we can also make them non-static, right? And that also works, right? And the only difference is, in the static case, I have to go, parser dot. In the other case, I do, your parser and then do it, right?
The thing with statics too is even if it's acceptable in some situations, it's not object-oriented programming.
Right, yes.
So even like math could be a singleton. Sometimes I wish it was because you could set, choose degrees versus radians. You could set the policy for overflow. You could set the policy for divide by zero.
Right.
I'm kind of limited by it being all
Static.
All those individual methods being static. But it's, even when it's maybe someone's design choice, it's not an object-oriented way to do it.
Yeah, that's why I keep on harping on static, because in the parsing case, we can still get global access, right? Because it's parser class and classes are global. Right? And the parsing in this example is pretty simple, right? And it's just basically tokenized by spaces. But if we had a slightly more complicated situation, you may want to have basically a stream of tokens, right? And then we can have we can create a stream tokenizer, which then has a pointer to where we are in that string, and then, say get next broken, and then it makes sense to have states, right? And since we've got a state there, then we want it to be an object. The same comment with gets and sets. If you go through your assignment, and some people have a lot of get methods, a lot of set methods. And it's like, okay, if your class is mainly gets and sets, where are you actually doing the work? So I spent a fair amount of time circling gets and sets. And then there was no, it's not Java, but we're declaring some field of property, caretaker, and it's like, what are you taking care of? Right? You didn't take the opportunity in the class name to specify what that caretaker is, but you have a field name, you could have told me what you're taking care of, right? And the only way to figure out what you're taking care of is then just to look through the code and see when you use it to see what you're putting in and taking out. Of course, in the assignment had a pretty good guess what you're taking care of, but generally, it doesn't tell us what you're doing, right? If we're using a state pattern, right, the goal is not to have to check for the type of the state or what it is to decide what to do. Right? The goal is we call on the state to do the operation, right? And then when the state changes, right, we call the same method on the state, but it performs differently. Right, so as soon as we start saying, well, if the state is equal to that, then we're not really using the power of the state pattern. We're just basically a flag, right? So there's nothing wrong with that, because if there's only one or two states, you only use it a couple places, then okay, fine, right? But if you're trying to show that you're using a state pattern, then in a class that talks about the state pattern, you'd want to avoid doing that. Now, a lot of people use a mental pattern, right, for undo. And in this context, mental pattern had a special challenge, right? So I have a bunch of spreadsheet cells, and this is a 5, right? And now I go and change it to different value. So when I change this 5 to say to be 15, and I use a mental pattern, well, I need to save the previous state of whatever was in that cell, right? But now the question is, when I press the undo button, which cell did I modify, right? Now, if I store the mentals in the individual cell, it doesn't help very much because I need to know which cell to tell undo, right? Because if I store the undos in each cell could have a bunch of undos. So which order do they come in? Right? So one solution people came up with, well, I'll just save the entire spreadsheet, which is going to be sort of expensive, right? Because every time I change a single cell, I have to save the state of all the cells. If you only have 9 cells like we did, or it was, it's not too bad. But if you've got 100 cells, 1,000 cells, right? Every time you change a single cell to save the state of everything, it's going to be expensive. Right? So the challenge then is, I'm using the mental pattern, I'm only saving the state of a particular cell. I also have to somehow store which cell it belongs to. Right? The next big thing was we now have a bunch of different things that belong, and they have to work together to get things done, right? So one obvious one is spreadsheet, right? Another one is Excel. So, what's the responsibility of a spreadsheet?
You have collection of cells.
There's a collection of cells, so manage a collection of cells, right? Well, yeah, for the Python people, it gets involved, but for the Java people, like, okay, that's going to be our model of which will connect up, right? So then we have to worry about all the methods that who is going to ask for. Let's say we had equation view and value view, right? Does that belong in the cell or in the spreadsheet?
Spreadsheet.
Because it affects all the cells, right? Now what goes in a cell?
Its value and its location. Where it is.
So we could have, let's call it as label, location, right?
Yeah. Value, expression.
Let me just. Now, one complication is That's an equation, right? What's that?
This is also an equation, but the value is also 1. So I can say equation is 1, value is 1 for the second cell. For the first cell, I can say equation is that is, and the value I can evaluate from that.
Now, as I said, we can treat that as a value or an equation, right? So does the cell need to store the actual value?
Not actually, but it's good to have it already computed inside it.
So one simplification to make is we may need to know the raw string, right? Because when you go to the equation view, you can display that. But at some point you want to evaluate it. You don't want the string, you want the parse tree, right? So one simplification is, I don't care what it is, it's always, our cell can always treat it as an equation. So if it's a 1, then you parse it and you get the parse tree of 1 node, which is a constant, and so I don't have to have all this value and equation, right? And people had, you were continually worrying about, okay, set the value, set the equation, get the value, get the equation. No, it can just, it can all be an equation, right?
I think, if I remember right, the way that it is, I also cache the value. I didn't treat an equation different than a value.
Right.
For all of them, I think I cache the value, and then that's when you use the observer pattern to update it, right?
Yeah.
You're just talking about not treating an equation versus a constant as two different things.
Thanks, right. Yeah, because some people actually had an equation, or whatever you want to call it, and they had a value, right? And so when it was, you had a method to set the value and set the equation, depending upon whether it's an actual equation or just a number, it's like, it adds more complication, right?
Actually, I treated it this way, but I'm calling raw string as an equation and equation as a value. But
The
the concept is this one only.
The terminology is,
Yeah, terminology is different, but yeah, equation value both are the same thing. I mean, it's just the value of that one.
right. Now, we'll come back to this in a minute, right? But now we need some methods, right? Because when we're in the equation view, we need to display, right, the raw string, which I called. And when we're in the value view, we have to display the value of that equation, right? And so now, how do we deal with that? And so some people have it, this is where some people use their static and like, okay, the cell needs to know what state the spreadsheet said to know what to do, right? It's like, no. So we need to, I want two methods, right? One method is, now this I get raw string, right? And I'll just, right, and I return it. Another one, another function, get equation value, right? And that has to return a double and we do stuff, right? And now, at least for the Java people, if we're using the table model, at some point our spreadsheet has to implement method, basically get, and I forget what the exact name of it, but it has to implement the table model, get value.
The value add, I think.
Yeah, that makes sense. And then we have row and column, right? But of course, now we want to call a different function depending upon what state we're in, right? And so here's what we're going to do the state pattern. So I have a, a view state object, And one state's going to be equation view, and another one's going to be value view, or whatever you call them. And now what we have to do is call our, so we have to return, well now we can do our view state, and what we have to call a method, and we'll just call it display value. And now we have to give it several things, a row and a column, right? And then we need, now the question is, how do the spreadsheet needs to have some way of dealing with all the cells, right? So how do we pass that into the state? Well, one way is when we create the state, we pass in reference, right? Or we pass it in here, and there's two different ways we can do that. One is we can just pass in reference to the spreadsheet, right? And then the state can grab the cells out of it, or we can have just pass in the cells directly, right? And so let's just say we've got some sort of collection of cells, right? So it may be a type cell. So now I can just pass in cells, right? And now one of my view states is going to call get raw string, and the other state, when I call display value, is going to call equation value, right?
Why wouldn't you just pass the cell there instead of passing it the whole collection and then telling them which one to grab?
I could.
I guess if it was a certain kind of array, you could.
What's that?
Well, I'm thinking in C++ you might not be able to if it's a certain kind of array, but I think in Java you were.
Yeah, Java's not a problem. C++ is, you're like, oh, passing in arrays, oh no. But so I could do that, just get the right cell and pass it in, and we're done, right? And it makes it simpler. So now the cell itself doesn't have to worry about what state the whole thing's in. Right? Now another issue is when I set the equation, we've got a problem, right? And that is the equation may reference other cells, and we have to parse it, right? So one thing we could do is we could have another class called equation, right? And then we can, it could have the raw string. And it could also then have the actual abstract syntax tree, right? After it parsed everything. But we also need to know all the things the cell depends upon, right? And when do we find that out? We find that out when we parse it. So if we parse it in the equation class, now our cell needs to know, give me all your dependents, right? And the other problem is when equations refer to other cells, at some point we need to reference those cells, right? Now, most people did is when they want to parse the equation for this cell, well, the parts in this cell, they then took that one and replaced it with that expression, right? And they then built up a one huge, they basically flattened the whole structure. Right? So when they parse this, instead of, there's two ways of doing it. One is, okay, when they parse this equation, it's just, well, the equation over here is going to have, well, there's going to be a plus, right? And then I'm going to have, I said, 2, I think. And then $sign A, right, for a variable. Now, some people did it, they did, oh, I'm going to have a plus, and then I'm going to have the 2, and then I'm going to have, actually it was a minus, wasn't it? Okay, I can't see over there. Minus, and then this is going to be the plus, and this is going to be, well, it was B, so that's going to now be 1, and that's now going to be another 1, right? So they basically expanded the whole thing out. And what's the problem with doing this? It means anytime we change anything, we have to go and recompute every tree for everything, right? Because since once I've got this tree evaluate, once I got that syntax tree, I have no idea where the cells came from, so when a cell changes, I don't know which one changed here. So I have to recompute everything. Now, of course, the way they finessed that was they never stored the output syntax tree. Right? They just computed it, evaluated through it. Which means every time you want to get the value of that thing, you have to parse everything again and evaluate it and throw it away again. Which eventually becomes more expensive, right? If I create an output syntax for each one and save it, I'm done parsing it until I change the equations. And when I parse it, I don't have to do this. I don't have to do this crazy, just go to each cell and grab their things. I can just parse that one cell's equation. Makes it a little simpler. And then when I want to evaluate it, I just evaluate it, and then I have some way of I have to then pass in. Well, there's two ways of doing it. One is I have to pass in those cell values, right? So I can then, when I get down to here, the variable node can do this actual value and return that value. Does that make sense? And of course, then if we're doing the parsing in the equation class, at some point I still have to ask it, give me dependent things, right? So I can register myself as observers from them, right? Which means at some point, when we set the equation we have to pass more than just the string to the equation itself. We also need to pass a reference to basically all these cells. Right, because otherwise, this cell needs a reference to all these. It'll go to and say, give me, register me as one of your observers. Right, so we have a set equation or set raw string, whatever you want to call it. Right, I need the string that contains that I got from the. But I also need all the cells, right? So that when I'm done parsing, I can actually go and say, I'm an observer, I'm an observer, I'm an observer, right? So we need a list of observers. Right. And now, when I want the equation value, I need those reference to those cells, right? So either I have to pass that here, so when I evaluate this, I can pass it in, or since on a set equation I stored it, I got it, I can store either in a cell or an equation, right? So that rather than making those right, so then to undo things, right, the spreadsheet has responses for that because it's the one that knows. Well, in the Java case, right, we have this get value and set value app, right? So every time you do a set value app, you then have to, if you use a memento pattern, you have to create a memento of the cell and somehow associate that with location, right? Or some indexing into the actual cell so that when we undo, right? And it also turns out, and a number of people discovered this, is that our cell has lots of stuff. They have a label, has equation, the raw string, and blah, 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 right? But you really only need to store that raw string. Because the label of the cell doesn't change, the location doesn't change. And when you insert the raw, set equation, it sets the raw string and sets the equation, and that triggers the observers too, right? So the memento for the cell basically has to store the raw string for the equation. The command pattern doesn't have that problem because the command pattern you store in the cell, right? And the previous state. And so some people realize, I could just, in my memento, I could not only just store that string, I can store the label for the cell too, right? So that when I get it out again, I can say, okay, memento, where do you go? And then we can pass it back into the cell to,
So that's what I ended up doing. I ended up putting the label in there, and I was kind of worried I was going to get marked down for that because it kind of violates the book,
Right.
which says, hey, you got to treat this thing as a black box until you give it back to its originator. Whereas I was actually pulling that out and then saying, oh, now I know where it goes. So it's a little bit of a twist on the book, but
yeah, but the book says, right, the memento needs to protect the value that came out of the cell, right? But the label or its location, when we get it right there, set value at, right? The alternative is memento is stored with something else. You create a tuple or something, or another object to store, right? Or an array of row index, column index, and memento, and you store that into the.
In this case, the memento didn't really have any secret information, so it was also kind of different that way. But if you really weren't breaking encapsulation by looking at that stuff.
Yeah, it's good practice, right? It was a challenging assignment, and also rather difficult to grade. Particularly with so many pieces that.
What about the circular reference tracking?
yes.
Were there interesting solutions to that, or did most people do it the same way?
No, people did it different ways. Some people will create a graph and then traverse the graph, and like, well, you don't need to do that because you already have the graph. So one way to do it is, so I have an equation object, right, or a abstract syntax tree. I can then build that into it, and that is. So we have an abstract syntax, we're going to evaluate function, right? Add another one is circular. And what you could do is, that is circular, you pass in the starting point. It could be the label, or some way to get the starting point, and so let's create a circular reference, right? So this one refers to B refers to this one, and now let's do that, right? So now the problem is I'm going to have three separate syntax trees. One is this, so I can't see that far. It's B plus 1. And then, so I have a plus, right? And it's a $B, and it's a 1. And the other one I just created is also a plus, right?
Yeah.
And then it's $A, and those two doesn't matter, right?
$sign C.
What's that?
That is $sign C.
C, right, C. Right? So this is for C, right?
Yeah.
And this is for A, and this is for B, right? So now what I do is I say, okay, I've got a function called isCircular, and I pass in the starting point. So I'll pass in this case, it's a $C, right? And I pass it to every place, right? And so constants ignore it. And the only nodes that deal with it are the variable ones. And they go, oh, is that me? No, it's not me. So it now has to pass it on to A, right? But it passes on the original starting point. And okay, no, not me. So I pass it on to B, and oh, I got back to where I started from. So it's now circular. Now I know it's circular. Which means I then have to mark all these things as being circular, right? But we can do that because I call the function, once I hit the same spot, the function unwinds. It comes back here and then back there, so I can now mark everything as being circular. And if you don't want to have a separate function, we can actually do it with evaluate too.
Yeah, I think I did mine with sets, and I had just the sets. Every cell knew its deep references.
Yeah.
It was probably more expensive up front, but then it was quick to evaluate.
A bit more, probably easier to understand than doing it that way. But I had hoped it end early because whenever we pass back assignments, there's always a bunch of people who've got questions by the class. So I do have a class at 7 o'clock, so I can't stay on for very long.
I'll be out of town next week.
What's that?
I'm gonna be out of town next week.
Okay. Okay, yeah, maybe.
Sorry to keep you.
Well, I have to be careful not to mix them up. Yeah, leaf is buried in the old ones, and then I can grade them, I don't find it.
I see four.